questions 11 through 20 of the 2001 Grade 9 Pascal Math Contest. Sahar walks at a constant rate for 10 minutes and then rests for 10 minutes. Which of these distance, d versus time graphs best represents his movement during these 20 minutes? So if he is on this graph where this is d and this is time, we are going to be continuously moving for 20 minutes. So t is definitely going to be going in that direction for a period of 20 minutes. And they've labeled it on each of these graphs as 10 and 20 like that. Now let's concentrate on the distance part of it. Initially, he walks at a constant rate for 10 minutes. So as he's walking, his distance will increase, correct? And it's going to increase at a constant rate. And then he stops and rests for 10 minutes. He's not moving. So his distance will not change. So it will be flatline like that. So this is the time that he's walking. And this is the time that he is resting. And which one of these graphs looks like that? Well, 11 is D. A bag contains 20 candies, 4 chocolate, 6 mint, and 10 butterscotch. Candies are removed randomly from the bag and eaten. What is the minimum number of candies that must be removed to be certain that at least 2 candies of each flavor have been eaten? So we've got 4 of these that are chocolate, 6 mint, and we've got 10 butterscotch, so 10 of these guys. And we want to remove a certain number that ensures that at least 2 of each flavor have been eaten. So this is one of those extreme case scenario questions. So if you were to, let's say, remove 10 candies, does that ensure that at least 2 have been eaten? Well, you might think, well, perhaps, right? Because 10 is a large number. But what if all 10 were butterscotch? Because remember, you're removing them randomly. You don't know what they are. You're not able to see them, I guess. They don't really explain that very well, but I'm assuming you're just grabbing them out of a bag. So if you grab 10, you could, it's unlikely, but it's possible that you could grab all 10 butterscotch. And if that is indeed the case, then you certainly haven't eaten 2 of each flavor. You haven't eaten any of the chocolate or the mint. So that scenario is not right. So we can eliminate A and B. How about if I took out 12? Well, again, that could be a scenario. You certainly haven't eaten any of the chocolate. So you keep kind of going like that, and you'll find that the only way is between now 16 and 18. So let's just go with 16. So 16 would be these 10 and another 6. So if we took out 16, it's possible that these would be the 16 taken out, the ones I drew a rectangle around. Even if you take out 16, it's possible that you still haven't touched any of the chocolate. So the only way to be certain is to take out 18. If you take out 18 candies, for sure you have eaten at least 2. Because with the butterscotch, you've eaten all of them. With the mint, you've eaten all of them, and with the chocolate, you've eaten 2. So that condition is satisfied. So the answer to number 12 is E. Pierre celebrated his birthday on February 2nd, 2001. On that day, his age equaled the sum of the digits in the year in which he was born. In what year was Pierre born? All right. So they give you some answer choices, and let's work through these. So we have year, we have the sum of the digits of that year, and we have his age. So if the year is 1987, the sum of the digits of 1987 are 25. And his age, if he was born in 1987, on February 2nd, 2001, would be 2001 minus 1987, which is 14. So does his age equal the sum of the digits in the year he was born? The sum of the digits in this year is 25, his age is 14, and those are not the same. So 1987 is not the year he was born. Let's keep going. 1980, sum of the digits is 18, and if he was born in 1980, on 2001, he would be 21. Well, these don't match, so 1980 is out. Let's try 1979. Sum of the digits here is 26. And if he was born in 1979, in 2001, he would be 22. And these don't match. 1977. Sum of the digits is 24. And he would be, if he was born in 1977, in 2001, he would be 24. So there you go. Finally, these match. So that means he was born in the year 1977 according to the criteria in the question. So the answer for number 13 is D. 20 tickets are numbered from 1 to 20. One ticket is drawn at random, with each ticket having an equal chance of selection. What is the probability that the ticket shows a number that is a multiple of 3 or 5? All right, so we'll write out all the values from 1 to 20. And the 20 tickets all have these numbers, all the numbers from 1 to 20. And then they're saying you draw a ticket at random, and you want to see if this ticket has a number on it that is a multiple of 3 or 5. So let's start circling numbers that are multiples of 3 and 5. Multiples of 3 are 3, 6, 9, 12, 15, 18. Multiples of 5 are 5, 10, 15, which is already circled, and 20. So out of the 20 tickets, how many are multiples of 3 or 5? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's basically how you figure out the probability of what they're asking. So the answer number 14 would be D. The line L crosses the x-axis at minus 8, 0. The area of the shaded region is 16. What is the slope of the line? Okay. So area of this triangle, which is shaded, is obviously 1/2 base times height. So the area they tell you is 16, and that is equal to 1/2 base times height. The base is from there to there, which is 8, right? Because this point is minus 8, 0. So that would be a distance of 8. You can't have a distance of negative 8. So the distance is 8. And therefore we can solve for h. So this looks like 16 is equal to 4h, and therefore h is equal to 16 divided by 4, which is 4. So that means that this point right here is 0, 4, like that. Okay? So now they want the slope of that line. Well, slope is equal to rise over run, as I'm sure you know. And the rise in this case is 4 minus 0. And the run is 0 minus 8, which is 4 over 8, which is 1/2. And therefore, the slope is 1/2, therefore 15 is A. In the diagram, all triangles are equilateral. The total number of equilateral triangles of any size is. So let's see. Let's figure out the triangles based on side length, and then we'll add them all up. So side length, let's see, 1, 2, and 3. I think that's about as big as we can get. And then how many are there? And then we can figure out the total down here. All right, so let's go with this. Side length of 1. Well, those are just the little guys like that. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's 9 on the other side. So that's 18. All right? Now side length of 2. Okay? We've got 1 there, 1 there, and 1 there. So that would be 3. And very similarly, you've got 3 on the other side. You've got 1 down here, 1 like that, and 1 like that. So that's 6. But there's 2 more. 1 here, and 1 here. Like that. So there was 3, 3, and 2, so that's 8. And finally, the equilateral triangles of length 3 are the biggest ones, the 2 biggest ones. So those 2 right there, and side length of 3. So that means there's 2 of those. So the total, 18 plus 8 plus 2, is 28. So 28 equilateral triangles of any size. So 16 is E. In the rectangle shown, the value of A minus B is. All right, so I blew the graph up a bit, and we're going to have to carefully look at this. They want us to figure out A minus B, so obviously we have to figure out A and B first. So A is here, and B is there. But they tell us that it's a rectangle. All right, so there's going to be some symmetry here, because lengths are the same, widths are the same, that kind of thing. So the first thing I'm going to do is draw a triangle between those 2 points like that. And I hope that you can see that that is a right triangle like that, or at least I've tried to draw it like a right triangle. And now I'm going to label the points that it makes corresponding to the XY coordinates. So if this point right here all the way down to the x-axis and this point down over to the y-axis can be determined, we will have some good clues. So let's figure this out here. This point right here has to be, according to what they've already given us, 5. And this point here is 2. Correct? So therefore, this point all the way down right there, and this point all the way across, we can also label. This is 9 and this is 5. Totally based on what they've given me. I haven't even calculated anything yet. So that means that from here to here is 9 minus 5, which is 4. All right? And therefore from here to here is 5 minus 2, which is 3. All right? And this, therefore, hypotenuse of that right triangle we can figure out. Either you can figure it out in your head, knowing that it's a 3, 4, 5 triangle, but if you're not familiar, you can just use Pythagoras for that hypotenuse, which I'm going to label as h. So this is 9 plus 16 is equal to h squared. H squared is equal to 25, and therefore h is equal to 5. So that's 5. All right? So I hope you understood how I got that as 5. And therefore this is 5, because it's a rectangle. The widths are the same. And in the exact same way, I'm going to draw the same triangle, but now over here. Exact same situation, exact same scenario. And I hope you see that that's also a right triangle. It's identical to this triangle right here. I just shifted it up. And that means if it's identical, then the sides are the same. This is 3 and this is 4. So now I can figure out this point right here. This point that I labeled in red. And I hope you can see that. We got to draw some lines now down to the x-axis and over to the y-axis like that. And let's label these points. So this point right here is 4 before 15. 4 before 15. Not very scientific, but that's okay. Therefore, that would be 11, right? And similarly, this point over here is 3 below 13. 3 below 13 is 10. So therefore, this point is 11, 10. Another way of writing that point is what? A and B, right? Look at it. It's A and B on the X and Y coordinates respectively. So we figured out that the coordinate AB is 11, 10. A is 11, B is 10. So they want us to figure out A minus B. Okay, no problem. A minus B is 11 minus 10, which is 1. So 17, the answer is E. The largest 4-digit number whose digits add to 17 is 9,800. The 5th largest 4-digit number whose digits have a sum of 17 is, okay, so 9800 has a sum of digits of 17. And they want us to figure out what is the 5th largest. All right, so we just have to start listing all of them. The next one is probably going to be 7. And if so, 9 plus 7 is 16, so I've got to put a 1 in here. And then the next one is probably going to be 9701. Let's see, 96. If I get 6, I've got 15, so I've got to put 2 more. So 1, 1. But I can also put 9620 like that, 9602. And then 9, 5, 9 plus 5 is 14, so I need 3 more to add up to 17. So 2, 1, 9, 5, 1, 2, and so on. 9, 5, 3, 0, 9, 5, 0, 3. So in a very non-scientific way, just based on inspection, I've listed some numbers that all are 4-digit numbers, and they all have a sum of 17, the digits. So I've listed about 10 of them, and now I have to rank them from first all the way down to 5th, like that. And then the 5th one is going to be the answer to my question, or the answer to the question. It's not my question. All right, so the first one, they tell you the largest one is 9,800. The second largest looks like 9,710. Third one, 9,701. And then the fourth one, I think, is 9,620. And then the 5th one is 9,611. Yeah, and then 9,602 would be the 6th one. But we don't care about the 6th one. So the 5th largest of all the numbers that are 4-digit and have a sum of digits as 17 is 9611. So that's C. Two circles with equal radii are enclosed by a rectangle as shown. The distance between their centers is 2x over 3. The value of x is. So first, let's label the distance between the centers. So like that. And they are saying that that distance is equal to 2x over 3. Like that. And then we can label a few more things. So for example, from here to here, that's the radius. From here to here is also the radius. And so would be those two lines right there. Right? Now, what is the radius? Well, we know the diameter is x, right? Because x is all the way top and bottom. So the radius would be x over 2. Like that. And we can label x over 2 all across the diagram. Now we get to the final part, which is looking at this length is 10. But the length here is also the same, right? That's also 10. But that part we have listed in x's. So we've got this x over 2 plus this 2x plus 3, 2x over 3, and then finally this x over 2 there. And now that all adds up to the entire length of that rectangle. But we know the entire length of that rectangle is 10. So we have to now just solve this math equation, algebra equation. All right, so we got x over 2 plus x over 2, that's x, plus 2x over 3 is equal to 10. So common denominator, 3x plus 2x over 3 is equal to 10. 5x is equal to cross multiply 30, and therefore x is 30 divided by 5, which is 6. So 19, the answer is C. Square ABCD has an area of 4. E is the midpoint of AB. Similarly, F, G, H, and I are the midpoints of DE, CF, DG, and CH respectively. The area of IDC is. All right. So we have a square of area of 4, correct? Right here. So if the area is 4, the sides have length 2. Okay? Now the first thing they tell you that E is the midpoint of AB. So if E is the midpoint of AB, AE from there to there is 1. And therefore EB is also 1. Okay? So that is the first part of it. And very similarly, we have to do that with all of these. So the first thing I'm going to do is look at F. F is the midpoint of DE. So that means that if you were to draw a line parallel to AB like that, F to AD would cut AD in half, right? That's the fundamental property of midpoints. So I'll explain that a little bit more. F is the midpoint of DE, correct? That's what the question tells you. So that means that DF is equal to EF. But if you draw this green line like I did, it cuts AD also in half. So that means that A till that point is the same as all the way down to the bottom. So that means from here to here is 1, and then from there to there is also 1. Okay? So you have to be convinced of that before we move forward. Same thing, same story. We now keep going like that. So the next one, of course, is going to be G, which is what I'm going to be concentrating on. So I'm going to draw a line through G like that. And in the same way that I had explained earlier, G is the midpoint of CF according to the question. So that means that G cuts CF in half. And therefore, if you draw that line like I did, it will cut this segment in half. Correct? Or this segment. It's the same thing. So that means that this part here is a half between those two green lines, and all the way to the bottom is half. Okay? So I hope you kind of see what's going on there. Let's say if we can keep going without, probably have to blow this up a little bit. I just don't want this to get too confusing, too small. Now we're going to concentrate on H. So again, I got to draw my line like that. And in a very similar way, by now I hope you get the hang of it. H, because H is the midpoint of DG, they tell you that. H is the midpoint of DG. It will cut this part in halves. So therefore, if from here to here is a half, from here to here is now a quarter, and from here to here is now a quarter. All right, we are almost complete. Finally, I is right here. We've got to draw this line through I. Okay, no problem. There we go. And not entirely perfectly drawn to scale, but it's okay. By this point, you get the hang of it. I draw a line drawn through it all the way to the sides. we'll cut that part into halves. So from top to bottom is a quarter, this becomes an eighth, and therefore this becomes 1/8, like that. This part is 1/8. So that means that the distance from I all the way down to the bottom right there is 1/8. So finally we can now figure out the area of IDC, triangle IDC, right here, I to D to C, right there. Well, that's 1/2 base times height. 1/2 base, the base is all the way from there to there, and that is 2, right? Because this is a square of side length 2. And the height is this little guy right there. And we figured out through all of our midpoints and lines that that was 1/8. So therefore this looks like 2 times 1/2 is 1, and therefore all you're left with is 1/8. And that for number 20 is B.